What we want to start off talking about today is kind of introducing the area of analytical chemistry. What is analytical chemistry? Um, you can make a nice distinction between chemical analysis and analytical chemistry. Analytical chemistry is a measurement science by definition. It's measuring some kind of chemical or physical property of a chemical species, either to identify it or find out how much of it is in a particular sample. And you can differentiate between chemical analysis, which is really using standard methods to find the amount of something or to get a concentration or a mass of an analyte, a thing to be measured, compared to analytical chemistry, which I really think of as kind of looking at the theory and trying to come up with new methods or improving methods to do chemical analysis. So there's a nice kind of definition there. It is a measurement science. You'll find it pretty much everywhere, anywhere that anyone wants to make any kind of measurement of a chemical species. So you'll find it in forensic science. It's applied in pharmaceutical analysis, in environmental analysis, in all kinds of materials analysis. So it's very, very common. It's used as a tool by lots of different scientists. A few definitions before we go on. A couple of things which you need to understand, a couple of words that you should understand. People will talk about qualitative analysis. That's really saying, what is it? So if you have an unknown, some kind of powder that you don't know what it is, then you would do some kind of analytical chemistry to identify it. So that's really what qualitative analysis is. Basically saying, what is it? What's in there? What's in the sample? Quantitative is measuring the amount, either usually as a concentration or a mass. So if we're saying, how much lead is in my tap water, that will be a quantitative analysis. You know what you're looking for. You know that lead is our analyte, the thing that we're interested in measuring. And in that case, our sample would be our tap water. A couple of other types of analysis. We can talk about characterization, which is trying to figure out like the structure, the chemical structure of something, or it might be a particle size or some kind of physical characteristic. So you're trying to characterize a chemical. And the other kind of analysis we'll call fundamental. This is really where I think analytical chemistry comes in. It's trying to understand the theory behind an analytical method, or trying to improve an existing method. So you're really actually working on the method itself. So that's fundamental analysis. In terms of the process of analytical chemistry, in the textbook it gives you this diagram. So there is a whole process. It's not just making the measurement. Making the measurement is usually a very small part of the overall analytical process. So we can think of it as initially identifying and defining the problem. In other words, what is it we want to measure? The analyte. What is the thing we want to measure it in? The sample. Okay. We also talk about matrix, which is everything in the sample that's not the analyte. Anything that could cause possibly interference, that will give a higher or lower signal than you should get. You also want to know what kind of information do you need. Do you need to know what kind of concentration range do you need to know? How accurate and precise do you need the measurement to be? You should also think about, is this a method that you need electricity for? There are usually limitations in terms of how expensive the equipment is, if the equipment is available. Is it just a yes-no answer? A simple kind of spot test, a simple test that just says, it's present or it's not present, or do you need to know it very accurately in terms of the amount? Then you come to the experimental design. So you establish what you need to know. Identify any interference that might be there. So you may have to reduce them or eliminate them, or pick a different method that doesn't suffer from that interference. You need to validate any method. That's basically saying that you know that the method gives the correct results. So there are ways of doing that. You can use a standard reference material where you know the concentration of the analyte, or you can compare your method to another method that you know gives correct results. You want to select the correct analytical method. If you need to sample, then you need to think about how you're going to sample. If you're sampling a river, do you take from the surface? Do you take from the river bed? Do you take from the side? Do you take from the middle? Do you take from all of those places and mix them together to get a kind of average result? So a sample should be a representative portion of the whole thing under measurement. The first step is actually to conduct the experiment, and to do that, if you're using any kind of instrument, you need to be able to convert from the signal the instrument gives you to what you actually want, which is normally a concentration or a mass. So there's normally a calibration involved there. Often we need to standardize reagents. We need to know the exact concentration of a reagent. And then we gather the data. Once you gather the data, the next step is to make some sense of the data. This is where statistics comes in. So you want to reduce that data down to kind of a central value and an idea of the spread of the data. That means doing some statistics. You want to verify the results. So this might be some kind of quality control or going back to method validation. And then you want to interpret the results. What do the results mean? So finally we have, is the data sufficient to answer that question? Do we need to do more analysis? Is there a different kind of question that's come up? And I would also add to that presentation of results. So you need to present some way or another. It might be an internal report, it might be a scientific paper, it could be an oral presentation or poster presentation, it might be a newspaper kind of article. So you kind of have to know your audience also. So those are the steps of the analytical process.